face. I don't know. All right, EX2. I'd like you to find. We'll do A right here. We'll do B right here. I'd like you to find the measure of angle QPS. Circle. I don't need a center. I do need a point of tangency. And I do need a tangent line. So, come on, ruler. Come on, work with me. Okay. Got ourselves a tangent line. Okay, let's put a point over here. Q, P, R is right there, S is right there. And I'm going to put an angle measure right here, 250 degrees. Now when you see something like this in the book, now I'm going to pause really quick to explain this, but some of you are still catching up with the drawing. When you see a number right here next to an arc, that's exactly what it's referring to. It's referring to this arc right here. That arc is 250 degrees. It's a big arc, folks, probably the biggest arc that we've seen. Remember, a full circle arc, if I went from here all the way around, that's a 360 degree arc. It's also called a circle, but we're at an arc of 250, so we're just shy of 360 from right there to there. I'd like you to find the measure of QPS, everybody, which is Q to P to S. I'd like this angle. How do we do this? Folks, that's an inscribed angle. That's an inscribed angle. That's an inscribed angle. That's also an inscribed angle, but as you can see, half of it is hanging outside the circle. That's the half I'm talking about that's hanging outside the circle. It's still an inscribed angle. It's half of its intercepted arc. 75, 150. This is an inscribed angle. It's going to be half of its intercepted arc. The intercepted arc is 250, so half of that, 250 divided by 2 is 125. That's 125 degrees, folks. Next one, a little tricky, folks. Circle. Let's freehand this. Ding. Call that D. Put an A right here. And this will be boy. That will be cow. Boy and a cow. Now I'm going to put 108 degrees right here. Let me talk about this really quick. When they give you a number inside an angle like here, they're referring to this angle right here. They're referring to that inscribed angle. Remember, I'm very careful with my terminology. This is what we call an inscribed angle. That's an inscribed angle. It's in the circle. That's an inscribed angle. That's an inscribed angle that's half of it's hanging outside the circle. Hopefully you can see the inside angle where half of it's hanging outside the circle. It's right here. That is an inscribed angle. Now I'm not going to ask you to find the intercepted arc. I'm going to ask you to find the measure of arc BCD, which is from here to here to here. This arc. Oh boy, how do we do this? How do we do this? It's really not that bad, folks. If this is an inscribed angle, find the intercepted arc. Find that arc first. Well, to find that arc, just double it. And if you take 108 and multiply by 2, you're going to get 216 degrees. Yet, that's not your answer, and that's not what we're trying to find. We are trying to find the measure of this arc, B to C to D. Question is, how do we do that? Also, consider what I just showed you over here. A full rotation on a circle is 360 degrees. If we started at D, if I go all the way to here, that's 216. And then if I continue from B back to D, Shouldn't that be a full rotation? Isn't that 360? So if you want to find what's left over, I'd say take the 216 and subtract it from a full rotation. And you should get, what is that, 144? That has to be 144 degrees. Because if you add these two together, it should add up to a rotation of a circle. 144 degrees, folks. I got one more theorem for you. I've named this one. This is a fun one. Here's the next theorem. Last one. I'll throw you two examples. We're going to call it. The special name for this theorem, I call this the 1/2 the big guy minus the little guy theorem. You'll see why I name it that. You'll see. You'll see. I'd like you to draw 3 circles. 1, 2, 3. It looks like a stoplight. Red, yellow, green. Every single one of these are practically the same. I want you to know that. Every single one of these. There's a reason why I call this the 1/2 big guy minus the little guy theorem. And they're all different. You'll see. You'll see what I'm talking about. In this first one, I'd like you to make 2 secants. So, and I'd like you to make. So notice, with this theorem, 2 secants, that's a secant, that's a secant. They're meeting at a point on the outside. And you can see it makes an angle. I'd like you to label this angle right here. Angle 1. No. I don't like that. I don't like that. I'd like you to label this angle X. Oh, I like that. I like that a lot. I'd like you to label the 2 arcs that are between the angle as well. So if I highlight this angle that we just created, you know, these 2 secants meet at an outside angle, we have 2 arcs that are kind of in the middle of this angle. The first arc is right here. I'm kind of highlighting it for you with red. And the second one is right here. These are 2 arcs that are between the yellow angle. I'd like you to label these. I'd like you to label the big one A, and I'd like you to label the big arc B. I'm going to call this the big guy, and I'm going to call this the little guy. The reason why I call it the big guy is because it's bigger. It's not rocket science. The reason I call this the little guy is because it's littler. And that comes from this little nickname I've given this, 1/2 the big guy minus the little guy. Alright, here's the first part of the theorem. X, that outside angle, is going to be 1/2 the big guy minus the little guy. 1/2 the big guy minus the little guy. There's the first theorem, folks. X is going to be 1/2 of A minus B. Let's do the second one. Second one down here, I'd like you to make 1 secant, and I'd like you to make 1 tangent. So it looks very, very similar, but a little different. I'm going to start off with my tangent. Okay. And then I'd like you to make a secant. Alright, hopefully you can see where the secant is. Hopefully you can see the tangent. The secant is the line that goes through. The tangent goes ding, hits the circle at one point. You've got 1 secant and you've got 1 tangent. Notice once again, just like the last problem, it meets at an outside angle. These two met at an outside angle. So let's call that X. And then I'd like you to label those 2 arcs in between that angle, A and B. I'd like A to be the big guy. I'd like B to be the little guy. Same as up here. Hopefully you can see the 2 arcs. There's the first arc. And here's the second arc. Hopefully you can identify which one is bigger and which one's smaller. The bigger one is A. Smaller one is B. Cool thing about this whole theorem, even though there's 3 parts of it, they're the exact same equation. The outside angle is going to be 1/2 the big guy minus the little guy. It's 1/2 big guy A minus little guy B. There's your theorem. Once again, it doesn't matter if you have two secants or if you have one secant, one tangent. Last one. Let's do two tangents. So let's, I need two tangents. There's the first one. Sorry, these notes have gone a little long. Sometimes we just have some long lessons. Two tangents. Notice once again they make an outside angle. Let's call that outside angle x. And notice how you have two arcs that are between the angles. Here's the first arc. And here's the second arc. Hopefully you can identify the big guy and the little guy. Big guy is obviously bigger. That's the A. And this is the B. Equation. Outside angle, the x, equals 1/2 the big guy minus the little guy. Every single one of these equations are the same, folks. Every single one of these equations are the same. Alright, let's do one last example and I'm going to call it a day. I was going to give you a two-part problem, but nah. Let's just do example 3. I'd like you to find the measure of arc BC. We'll do one quick example just to make sure this makes sense up here, and then we're going to call it a day. Draw your circle. B. B. That's going to be B. That's going to be C. That's D. There's A. I want to tell you this is 141 degrees. I'm going to tell you that this angle right here, that acute angle right there, is 62 degrees. And I would like you to find the measure of arc BC. That one. Now, in these problems, the x was always representing as the outside angle. That's the 62. There's the little guy, and hopefully you can see the big guy. Set up an equation and solve for x. Let's call this little guy x, because we already have the big guy and we already have the outside angle. So the outside angle is going to be 1/2 the big guy minus the little guy. Let's solve for x. Multiply by 2 on both sides. 124 equals 141 minus x. And if we subtract 141 on both sides, what is that, a negative number? That's okay because you have a negative x on this side. Negative x comes down. 121 minus 141, what is that, a negative 17? And then if you divide both sides by -1, you get x equals 17. Folks, that little guy, that little arc, is a 17-degree angle. Alright, homework. Let me get your homework down and we'll call it a day. Page. Let's see, this is 10.6. Make sure I get you the right homework assignment. Page 745. I'd like all of you to do 8 through 10, 13 through 16, 18 to 22 even, and 26. Folks, have a good weekend. Make sure I get this assignment by midnight. I got to keep writing that because some of you are still not turning it in, or you're turning it in the morning the very next day. Have a great weekend, folks, and we'll see you on Monday for the last lesson in the chapter. So long.